All right, good afternoon. My name is Kevin Espinoza, and today I'll be presenting my Far and Beyond, which is my Stars, Galaxy, and Universe project. And with the first question, what are at least three properties of stars, and what have you learned about them? Well, a star can basically be defined by five basic characteristics, which is brightness, color, surface, temperature, and size and mass. And I would like to apologize right now. I kind of messed up my camera the other day, but yeah, I'm getting it fixed right now. This is pre-recorded too. Another thing is that color is a clue to a star's temperature. When it comes to temperature and because color is kind of it's affected by temperature of the star, and astronomers measure mass by using Newton's theory of gravity. And the next question is, what is stellar parallax and how does it work? So basically, there's a shift of the position within the stars. Usually, the nearest stars have the largest parallax angles, and those who are much distant have the smallest to measure. And pretty much the way it works, parallax measurements work by, measuring the relative change in the position of the sun as the Earth goes around the sun. As you can see here in the picture above, right here in the top right. And what are two ways star brightnesses can be described and how are they different? Well, the star and the night sky have an assortment of sizes when it comes to like temperatures, brightness and distance and all that. And these are described when it comes to apparent magnitude and absolute magnitude. And a paramagnitude describes how bright a star appears from the Earth, and absolute talks about um, how the magnitude of a celestial object is seen from a standard distance of 10 parsecs. And that's pretty much just brightness right there. And what is the HR diagram and what does it tell us about stars? And pretty much the HR diagram is a graph that shows the relationship between the star's temperature and absolute magnitude. And the differences we can see here is that, the left of the diagram usually the location of the hottest star. The right side of the diagram is usually the location of the coolest star. And the top is usually always the brightest, and the bottom is always usually the dimmest, as you can see here. And what are different ways stars can evolve? Well, there's a way, it kind of just depends on which the star evolves, depend on, there's a total amount of 7 steps, for example, nebula, protostar, main sequence, red giant, supergiant, planetary nebula, and so on, so on. Basically, stars are born within clouds of dust and scattered throughout most galaxies. A familiar example of such a dust cloud, is in the Orion Nebula. And pretty much these are like the birth of stars and like the whole way they're created and stuff like that. It's pretty awesome. What are different types of galaxies? Galaxies, pretty much what galaxy is like a large group of stars that contain dust and gas. And galaxy clusters are pretty much like it's pretty much galaxies like grouped into like large clusters and stuff like that. And spiral galaxies are pretty much usually like disc shape, as you can see in the image up here. Like when someone tells us how does a Milky Way look like, it usually looks something like this. And elliptical galaxies are about only 60% of the galaxies that are classified. It's probably only 60% of them. And the thing about these is that the range in shape usually they're oval shaped when it comes to elliptical galaxies, and irregular galaxies are only about 10%, so they're kind of rare. And they're used to having like irregular shapes, like the most, like regular shapes. Like it could be like I don't know, like circle or stuff like that. And what are the characteristics of the Milky Way? There are four main parts: is the nuclear bulge, the halo, and the galactic corona, as well as the disk. And the spiral galaxy whose disk is about 100 light years wide and it's about 10 light years thick at the nucleus. And the next question is going to be, what is the evidence that the universe is expanding? Well, this has to deal with redshifts, and it's basically the increase of a wavelength from a galaxy moving away. And yeah, and basically in redshift, the light coming from the distant galaxy provides evidence that all parts of the universe are expanding. And what is the Big Bang theory? Pretty much a theory created about, you know, how our world was created, or I guess you could say our whole galaxy. It pretty much talks about how we were all the galaxy was created and all that. A big explosion ended up creating gas and rocks and stuff like that. That's what formed the Earth. And the Orion constellation is usually the most important constellation. It contains one of the most nearest and most active stellar nurseries. And the most famous stars are the Rigel and the Betelgeuse, and these are the brightest stars within the Orion constellation. Thank you very much, and I hope you have a good one. And have a good retirement, Mr. McCall.